The longest we have casted so far is 2.2 meters from gating to the end of the cavity in a 600-ton die-casting machine.
600 ton.
Yes.
Yeah, it's usually the Megacasting or the Gigacastings are again in that range, 1.5 to 2.5 meters, but on something like 6,100 to 9,000 ton machines.
It feels like we forgot a zero here.
Exactly. And especially if you compare it, you would do it something like these coming from the slushy machine from the gas station. How can you be that good with something that's basically part solid?
Exactly. That is the difficult thing to understand and to accept, I think, as a human being that is working with liquid, so to say. But there are several things.
Today, we are pretty proud to have the third episode in our special focus series about Gigacastings. And today we are even more happy because we have together with us Per Jansson, founder, owner, and CEO and CTO of Comptech Rheocasting. So welcome, Per.
Thank you very much.
Would like to mention a few words before we start also. Today is actually the world premiere for something else. This is the first podcast that we're doing now with a sponsor. And today's sponsor is Mr. Per Jansson and Comptech Rheocasting that has chosen to become a sponsor of Gold Casting. Very happy about this. Now, Mr. Jansson, you have been participating in our podcast, what is it now, 6 months ago? But for new listeners, we would be happy if you can make a short introduction of yourself.
Yes, my name is Per Jansson, and I have been in the die-casting industry basically my whole life. I started running around in a foundry as a young boy and have worked in basically all different areas you find in a foundry. And since 2008, I have started Comptech with the intention of showing the world how fantastic Rheocasting is for the high-pressure die-casting community. So that's basically me.
That's exciting. Can you tell us about Comptech a bit more?
Comptech was founded in 2008 with the intention of running a foundry with Rheocasting, but as we went along as being a foundry, we have changed our scope and our business model since we have entered several projects which were so large that they weren't able to be put in place by one single foundry. We changed the business model into selling equipment that make each existing die-casting cell into a Rheocasting cell also, in order for several foundries to share the market within Rheocasting, basically, we can say. So we have gone from being a foundry into a technology provider and an equipment builder. So that's basically the journey we have made since 2008, where we started with the conventional liquid high-pressure die-casting, together with then semi-solid Rheocasting. So.
That's actually something you can do a pod episode only on that transition.
Yeah, it has been quite some headache.
It's been quite some. A few painkillers, a lot of Swedish snooze, and maybe a beer or two on the weekends. Kind of appreciate the effort.
But that makes it even more interesting to talk about a technology that led to that change that caused that many headaches.
Yeah. Basically, I mean, what caught my interest in semi-solid casting is actually the most counterintuitive way, basically, that you take an alloy and you make it like a slush or a slurry, and then it actually lives much longer than a liquid casting, which is difficult for the human brain to actually accept, but that's exactly what is happening with Rheocasting, and I think that all die-casters should experience this. It's a aha and a wow feeling.
But given the history here, we understand many years has passed. Where would you say Rheocasting is in terms of rollout now?
I would say that it is in the beginning in many different market areas where people are getting up the awareness of Rheocasting, because I think Rheocasting is solving a lot of problems which you can't really solve with conventional liquid casting. My guess is that Rheocasting is going to increase and get more widely spread and known in many areas actually.
And now, among everything that you can work with, apparently Rheocasting is of interest for the Gigacasting society. Could you give a brief overview why this is the case?
Yeah, first of all, it's very large casting. You can basically hear that from the name, right? So that means that the metal has to pass quite long distance. And the easier the metal can flow, the easier the component can have equal properties all over the full length, so to say. And I think this is the initial major contribution that Rheocasting is giving to these very large structures.
How long can you cast with Rheocasting? What is the longest flow length you have casted?
The longest we have casted so far is 2.2 meters from gating to the end of the cavity in a 600-ton die-casting machine.
600 ton.
Yes.
Yeah, it's usually the Megacasting or the Gigacastings are again in that range, 1.5 to 2.5 meters, but on something like 6,100 to 9,000 ton machines.
It feels like we forgot a zero here.
Exactly. And especially if you compare it, you would do it something like these coming from the slushy machine from the gas station. How can you be that good with something that's basically part solid?
Exactly. That is the difficult thing to understand and to accept, I think, as a human being that is working with liquid, so to say. But there are several things. I mean, first of all, we have isotropy that the aluminum slurry provides, which means that the more we share it, the easier it flows. And the plunger in a die casting system is a fantastic sharing device that will make the alloy to be shared all the time and provide, how should I say, the life of the metal. Then we have the contact with the tool steel are so much poorer due to the solid particles inside, which means that the die have more difficulties in cooling the metal down, and that also helps the metal to flow longer.
Cooler? How much cooler?
Yeah, I would say around somewhere, depending alloys, we're talking about, say, 80 to 100 degrees colder when we pour it in the shot sleeve, which also helps, of course. Another issue that we have with these huge, very expensive dies and equipment needed, that is also increasing the lifetime of all these things. Almost you can probably get double the lifetime from a die compared to liquid casting.
Double the lifetime, especially for such expensive tools. That's quite a number.
Yeah.
So why doesn't everybody use it?
Yeah, I'm the wrong guy to answer that question, actually. But I can't understand that either. But the more we can inform the market and the more information that are obtained, I think we will come to a point where people actually is going to try it out also for these applications.
But it's fair to say that you're working with Gigacastings, right?
Sure, we do.
It's fair to say that you have signed NDAs that probably will throw you in jail if you reveal too much.
Yeah, we have signed NDAs anyway, if I say like that.
Yeah, we have signed NDAs, and I hear multiple, plural. Is there a common question from the OEMs to you when it comes to Gigacasting?
Another topic that we really haven't touched yet so far is also the fact that when using Rheocasting, we also enable the usage of a smaller die casting press, so to say, from a locking force perspective. I think this is one very common question. How much smaller die casting press are able to be used, so to say. Another topic is, of course, the alloy. What alloy should these huge castings be casted with in order to achieve the best possible properties? And then, of course, again, we also have the sustainability discussion. That is also something that is coming more and more.
You mentioned a few things now in the last sentence. I think we have to go into each of them individually. Let's start with the machine size reduction. So we all know the larger the machines, the costs are going exponentially up. Now it's the interesting thing, how much can you reduce the machine?
Yeah.
Do you have some numbers there?
Yeah, that is of course very much dependent on which castings you are going to cast. But as an example, we have casted a casting with a very long flow length, 2.2 meters as mentioned earlier. The projected surface on this shot is approximately 33 square decimeters, and we casted that in a 600-ton die-casting machine with roughly metal pressure, I would say around 200 bars, something like that, where we also obtained very even properties from the beginning to the end of the casting, and also a reduction of porosities compared to liquid casting with about 50%. Whether these numbers can be transferred directly into a large mega casting is something I can't really answer without have the experience of doing it. But as you understand,
But isn't that the problem, that no one has experience?
No.
It's a new part.
But I once learned rule of thumb when I started in this industry 30 years ago. It's roughly, if you want to make a quick calculation in how big die casting machine that is required, calculate about 100 ton locking force for each square decimeter. So that tells us that this large casting that we made in a 600 ton should be equivalent to roughly 3,000 ton, but it's made in a 600 ton. Whether you can go that big drop, that is yet to be proven.
It comes down basically more to the tie bar distance.
Basically. Let's say that with Rheocasting you get a very high yield on your machine table.
But with your experience of these projects then, what do you see as the biggest problem that the OEMs have with their gigacastings?
I mean, we talk about the automotive industry, and we all know how the automotive industry is when it comes to quality and uptime and efficiency and so on. I mean, it is probably the world's most competitive market to be in, meaning that the uptime, quality output, and the ability to plan, I think this is the biggest headache when it comes to these large machines. I mean, you need to be able to plan how often should I take down the shot sleeve due to wear? How often do I need to take down the die in order to make my maintenance and so on? And know that this is the fact. And I think the one that has the longest intervals here has a huge advantage. And also knowing that the output is what we have planned the output should be.
What you just described makes me feel that this should be a Japanese sport rather than a sport in other countries.
I mean, they are very good in this. If we look at the Japanese, how they face quality and all this, and they are very structured and so on. So I'm sure that they will be very good when they apply these tools that they have developed over the years also onto this technology.
Interesting.
Then it would be probably heaven for them if you told us earlier the properties are more uniform throughout the casting, and everybody knows from high-pressure die casting you always nail the properties at the ingate and you get the problems at the end of the filling, and it won't be better after 2 meters of fill length.
Exactly. I think that's the one huge advantage.
Alloys. What do you see around alloys?
I think that sustainability is something that is increasing. Everybody wants to be able to cast with a more dirty alloy, but maintain their properties. Meaning that you need to be able to have a process that can create as little defects as possible in order to enable to use a more dirty alloy. I think that is something that is coming more and more. And we have also learned that different alloying elements increases the CO2 footprint. So being able to cast with an alloy that allows as small CO2 footprint as possible due to its composition, that ought to also to be an advantage.
So when you talked earlier about dirty, you mean the elements that are within the alloy and not the CO2 footprint. So what's the key to getting sustainable and highly recycled alloys? And why are they especially useful for Rheocasting?
I mean, Rheocasting require a solidification interval, and the more we can move away from the eutectic point in an aluminum silicon alloy, the larger process window we have in order to create a slurry. And that means that if we take silicon, for instance, if we can reduce that, we both increases the process window of creating a very stable slurry, but we also help the casting to have a lower CO2 footprint at the same time.
I have to dig a little bit deeper there. I was under the impression that in the old days, meaning 1 year ago, everybody was looking at aluminum silicon 10 alloys. That's like the standard composition give and take for making some kind of structural casting. And then we hear about companies in the US using aluminum silicon 7, aluminum silicon 8 somewhere. And then all of a sudden, we also understand that elongation is the big driver here for meeting requirements. But high-pressure die-casting of aluminum silicon 7, that's not super easy, right?
No, that gives certain challenges.
Yeah, because we have high speeds and we have a nastily big tooling.
And also a large solidification range.
Yeah, and now you say that with aluminum silicon 7, all of a sudden you increase the process window of Rheocasting.
Correct.
How low would you like to go?
We have tested alloys down to 2% of silicon, which doesn't give us that huge different, or not different, but difficult casting parameters, if I say like that. So somewhere.
It's more up to the customer to decide something with a low silicon.
Yeah, let me say like this: there's probably going to be a lot of alloy development in the future, because we have added another tool in the toolbox, because we still provide the castability, which you don't really have when it comes to liquid casting. Meaning that the castability, what I mean then is that you can reduce the silicon content and still cast very thin walled castings.
I think we should give our listeners a bit of a background information. So not everybody is too deep into high-pressure die casting. Usually high-pressure die castings alloy have around 10 to 12% of silicon, which is exactly around the eutectic spot. So you have a very small processing window, which is ideal for liquid casting. But you have a lot of silicon needles, which requires a heat treatment, and you don't want to have a heat treatment on such a large casting. Therefore, you go down to 7% silicon to reduce the silicon content, but you also reduce the castability. And the interesting thing, which we can take out from here now, is that the silicon content doesn't really play a role in the castability with Rheocasting.
Correct. So you can obtain properties in perhaps obviously in us cast state. I mean, if you can do that instead of with heat treatment, where you get other problems such as warping in the heat treatment and so on, and then you need to straighten the part, can you have as little variation as possible, and perhaps in the end you can also get the casting out without needing any post operation such as straightening and things like that. It's more uniform. You get a more stable, complete process chain of these large castings with the required properties. But this is not my field of expertise. I mean, we have probably a ton of different metallurgists in the world that are able to design these alloys.
We shouldn't make them unemployed by giving them a solution in this podcast, even if it would be pretty cool if the solution was here. Speaking about something completely different, we had some guests in this podcast that were a little bit more circling around the area about risk mitigation. the number of people working in the projects and how to cope with all these big investments. Do you see risk as a higher force or more driving factor around gigacastings and than other castings?
Especially when you also consider that gigacasting parts are just one cog in the wheel of the automotive production and not just a foundry somewhere.
Well, I think in many cases, I mean, first of all, when we talk about risk, there is a lot of new foundries then is being started that have no experience in the casting industry, which is of course a risk. And perhaps let's say that the starting stretch is perhaps longer than for those who is starting with these huge castings, so to say. But the risk in the terms of compared with what?
Risk of not supplying the car assembly line.
That is of course the risk. I would say that is that they don't have enough capacity, and since this is a process, and perhaps knowing the automotive industry in how they do, and I doubt that they can treat a die casting cell in the same way as they treat a sheet metal press, so to say. I think there has to be some kind of buffer stock in between, because there will be problems that you don't have when you talk about sheet metal forming. I mean, sheet metal forming has probably its own challenges and problems, but to me it's more of a cold process. Now we talk about the hot process and what all those things mean to it, so to say. I think this might be a risk that they are too close to the, how should I say, the distance between the output from the die casting and the need from the assembly line is too narrow. So it doesn't allow for problems in the die casting operations.
But given the sum spent in this, it must be the best thing that has happened for people that wants to make a career inside the die casting industry. I mean, if there are that many newcomers, to put it that way, car makers that needs to invest in huge machines. I mean, everybody from maintenance people, computer science people, metallurgists, foundry guys, tool makers. It must be great for our industry.
Yeah, sure. It's fantastic. It's the best thing that happened since it's a revolution in the industry, I would say.
How will it affect you, this revolution?
Well, I mean, from being a die caster, learning about technology and so on, I think it will drive the development. I mean, take my little company. We are just a part of it. We try to persuade the industry that make a metal treatment on the alloy before you cast it. It will open up the process window for you. Basically, that's what we do. So we are part of this evolution, I would say, of the casting industry, enabling more applications to be cast that can't be casted today. Now we just talk about gigacasting or megacasting, which is just one opportunity. But so I think this will be very good for the die casting industry as such.
Do you think everybody will find people to employ then? I mean, basically most platforms will be there 26, 27, 28.
Yeah, but if this is a way of assemble a car, this will drive a need for people and so on. Initially, it might be a little bottleneck to get people, but if you look a little bit longer in the horizon, I think this will also feed new ways of educations and new ways of attract people to this industry. I think.
What do you think about the usual specifications? That in automotive, everything is highly specified, and a high-pressure die casting process, as we already know, we have differences between the gating area and the overflow area, and that's really hard to put into specifications. And you said that we have more uniform properties, so wouldn't that be part of a risk mitigation strategy?
Sure, it should be, of course. Everything that enables us to a lower risk that ought to be implemented ASAP. So I usually compare die casting with a decathlon race. That means that you have to compete in 10 different sports. And it doesn't help if you are very good in 3 of them and useless in 7. You will not win the Olympic medal, gold medal. You need to be good in all 10 different fields, so to say. And it's basically the same with die casting. You cannot pull one out. It is like a cogwheel. Everything has to fall in place at the same time. And this, I think, is also a big change in way of thinking.
But what would be your 10 disciplines in the high-pressure die-casting industry that a new OEM has to master to build up a car with a Gigacasting?
Let's say buying the die-casting machine, that is the simplest thing of them all, I would say. then I mean, it's there are so many things. I mean, just in how you design the tool is one thing. You have a lot of things there with material choices, etc. How to make the cooling channels and so on. And before you even come that, you have the simulations that is needed to do in order to get as right as you can from the start. Then you have the complete spray process of the casting, and then you have the material choice in the alloy and the metal treatment process and so on. And then you have the actual die casting, the shot profile and so on. And then are you going to use vacuum or not? And then you get the part out of the die casting machine, and then you need to have the post processing of the casting itself, trimming and how to remove the gate and so on. And then the design of the whole casting. Should I cast the holes or should I machine the holes afterwards? And so you can, there's a lot of things that need to work before you have a casting that you can assemble into the car body.
And there's no one
There's
to
no
ask.
one to ask.
I mean, it's a new part. If you want to ask something about the shock tower, you can find probably 3,000 people that has been around the shock tower.
Today, yeah.
Yeah.
But the guys who invented the first one and did the first one, they couldn't ask so many.
They couldn't ask so many, no. But if I pick up the phone and call someone in Fremont, California, I'm not that sure that they will reveal how they're thinking about problems and how they solve the problems. Probably not.
I think probably calling any OEM and asking them how they solve their biggest problem, you won't get an answer.
But still, all these problems that we have now talked about probably are less problems that what they face today compared to it replaces, what is it? I've heard everything between 70 to 130 other pieces. So I mean, still, it's probably one way of risk mitigation anyway, that you go casting instead of how they have done it.
So what you're saying, even if the machines are expensive, they're probably worth it any day.
That's what I'm saying.
So it's all about money in the
It usually is.
It usually is. Yes. And that's a good thing, because we're not supposed to speak about technology in this pod, but now when we started this series about Gigacasting, we start to discuss atoms and magnesiums and straightening and machines and shot profiles. And so I think there's a conclusion to be made. To pull this off, one actually has to look beside the price and the money of a part and actually start to speak about casting again.
Yeah.
I mean, my point is, how much do you think to speak about technology when they do shock tower number 13 for a high volume car? I think it's quite given. It's just about the price. But now the cost is important. The cost of ownership of the machines, the cost of ownership of running the machine, the process cost is a new thing. I mean, if you take a Gigacasting cell, you're supposed to squeeze out, 60 pieces an hour? That's 3 tons of aluminum, if I don't make a wrong calculation, per hour. It's not a small foundry with, Staffan, Luigi, and Per running around with 5 machines in the woods in Sweden anymore. It's a process industry.
Yeah, well, I would say it's a factory within the factory.
Yeah, well put.
First of all, and then one have to put that in context in what are they gaining in doing this, and where is the benefits. Now, if the casting is so darn difficult. Why is people doing it? I mean, the earnings and the benefits has to be so much greater downstreams, so to say, so it's still worth breaking your back in trying to cast these huge structures.
Yeah. It cannot only be fashion. It
You
has to be
mentioned
money.
it before, it's all about the money.
So one question we have to put here, we all run around Eurogas every second year. Will we see Gigacastings made with Rheocasting in the next Eurogas in 2026?
We'll probably talk.
Or is that too close to the NDA?
Yeah, let's say that the talk about Rheocasting 2026 will probably be much more broad than it was 2024, if I put it like that. Whether it's only about Gigacastings, but I think there are also in other applications we will see it. My bet is that the biggest topic in Eurogas 2026 that will be about sustainability.
Why?
1st January 2026, we will have CBAM going from monopoly money into real money.
Yeah, usually, as we already heard, as soon as it costs money, people start to think how to not spend
And
it.
people are waiting in the longest to do something, to see, do I really have to do it? And when it starts to hurt, then you have to do it. And most likely this is something that is going to start hurting. So we will probably see a lot of buying organizations going around in Eurogas 2026 trying to find more sustainable options.
So anyone who wants to make some money in the foundry industry all of a sudden had at least a field defined by Dr. Per Jansson, who claims that in 22 months from now at the Eurogas, if you're standing there in the booth and have a solution about sustainability, you will be one of the winners when you take your flight back home from Frankfurt in the evening on the third day. Is that the way to interpret
I would
that?
say yes.
I want to ask you another thing, which is the flip side. We already heard that it's something from 70 to 130 pieces that are integrated into Gigacasting. And we talked a lot about now Rheocasting for Gigacastings. What can you offer all these other foundries which lose their shock towers, longitudinal members, cross beams?
Exactly. But with Rheocasting, you are, as we have been into that topic a little bit, we enable a greater variation of alloys to be cast in a high-pressure die-casting machine. So, for instance, take all parts that is being gravity die-casted, low-pressure die-casted, and so on, usually using the ALSI7 alloying system somewhere. That will all of a sudden be a target for the high-pressure die-casting community. And I would say that this business is probably equally the same size as the high-pressure die-casting industry. But we are also now making that a target for the high-pressure die-casting society.
Interesting. So if you lose your business, you should steer your sales guys towards what the low-pressure die-casters and the permanent mold guys are actually casting. And why should an OEM customer buy that solution?
First of all, a high-pressure die-casting cycle is probably much more faster. We have a shorter solidification, a quicker solidification, which means that we get smaller grains. We get better properties from the start. You could probably get away with a T5 heat treatment with Rheocasting instead of a T6 as you do in gravity, and i.e. you should get a cheaper product.
It's again the double punch, more sustainable and cheaper.
Yeah, definitely.
Oh, that's great.
To me, this is the lowest hanging fruit, if I say like that, to be picked by and I think it's not because of the introduction of gigacasting and megacastings that make this happen. I think it's the complete electrification of the vehicle fleet that actually drives this. I think that we cannot stop the electrification, that will go on, and we will see more and more of different types of electric vehicles in the future. We see a huge invasion of new brands and new models and so on from from China and so on, which ought to make the foundry community a little bit worried, because the cake will shrink, and I think that foundry owners should actually think, what do I want to do with my foundry in the future? And one solution could be to invest in Rheocasting and use the already made investment they have in the high-pressure die-casting foundry, and look what other applications can I cast with this. And then I think this is one simple thing to do, because you use the same alloy that the parts are already made of today.
But you're stepping out your comfort zone. You have to meet new customers. You have to understand new applications. You have to go an extra mile in another direction.
Exactly.
I mean, entrepreneurship, fantasy, creativity has never been that well paid for in the industry between the car maker and the foundries.
No,
right?
I think not. But equally, it will also become a problem for the buying organizations. I mean, when you see foundries are getting out of business and so on, they will have problems in sourcing as well. So I think it's equally a responsibility from the buying organizations.
I think I read that article you wrote about the panic in the die-casting industry.
Might be
actually
too early.
That was one of the main topics you had in the conclusion side. Yeah.
But I think.
And that was written,
yes,
3 years ago?
Even more, right? 4. I think it was for the Eurogos 2020, actually.
So probably written in 2019, as the Eurogos is in January.
Yeah.
Yep. But can you give us a more outline? You said the lowest hanging fruit will be the gravity, low pressure die casting parts, take them into Rheocasting. What would be a way up the tree with other possible applications?
Yeah, I mean, if we take this, I mean, structural castings is difficult as such. It requires a high-end process. It requires high-end equipment in order to be able to provide that. You basically need to be very good in all these, as I said, all these 10 different steps, so to say. But there are other, I mean, we don't really either know what the future holds in what they can develop in new applications and so on, because I mean, this is part of the problem, right? In the foundry industry, we always compare with what have we cast before and what can we cast tomorrow, and we look at this is a casting, this is an application that we need to find other applications. And I mean, thinking this out of the box, that I'm going to do high pressure die casting of a gravity casting that is 50 millimeter thick. You wouldn't think that if you only do liquid high pressure die casting. So you need to think differently and try to find other application. And what's at the top of the three? I think these mega and gigacastings, I think is at the top of the three. I think that is difficult ones. But I mean, what happens if we can develop new alloys that we can join together with different methods, with other metals and things like that in the future that could be cast? Because casting is a fantastic process, because it's a very fast way from raw material to almost finished shape. But we should do that with more materials. I mean, I think it's also possible to make a slurry out of iron. High-pressure die casting of iron.
So that opens up many ways, and you just have to find a material that you can do liquid or Rheocasting, iron castings.
That is something probably going to be. Can you do high pressure die casting of iron particles, steel?
What do you use for tool steel then? Some odd ceramic.
Or some tungsten.
Ah.
Which will make the tools way heavier.
Yeah. But maybe you don't need to make a gigacasting an hour, right?
Perhaps you shouldn't.
No.
But imagine the revival of the sheet metal guys. You go over aluminum castings for 10, 15 years, and then Mr. Jansson develops the steel casting of 2.5 millimeters. Then all of a sudden we have a three-dimensional sheet metal product. Now I've been eating too many mushrooms again for lunch.
Exactly. But I mean,
Yeah, but I think that gives a good idea how much creativity you have to put in and not just go, if we cast shock towers, then we can cast
exactly.
longitudinal members. It requires way more creativity and way more business development. How do you see the business development of foundries?
Yeah, I think the business development in foundries the high-pressure die-casting foundry business is usually a sub-supplier type of business, so to say. I mean, it's someone is coming with a drawing saying, can you make this for me? And then there are several others that can make the same thing, so to say. So what's differentiate one from another, so to say? I mean, it's relations and so on. But I mean, we have to add into this equation that you do something else that nobody else is doing, so to say. I think this fantasy here needs to, well, let's say it can evolve quite a lot from how it is today. What can I provide, and what value do I provide to my customers?
It sounds like a fun foundry to work on, but also a challenging transition to go into a culture that is embracing.
Yeah, and it's not also. I mean that is how the business model have looked for foundries for many years. It's like hairdressing. Why do you go to one hairdresser, not the other?
Are you asking me?
Perhaps
really?
Not you, Staffan, but
you see,
but basically it's the same business model, right?
it's basically, yeah.
Yep. You're used to the business model, or you're used to that hairdresser, and then you just go there and do it like you did before, and good to go.
Yeah, there you go. So, great talk. We understand a lot of things, but we're still confused on a high level. So we can definitely dig in more into why is Rheocasting working, but I think that requires a little bit more of a PowerPoint movies in depth. We understand another thing, that there's a process window to be looked after here. We understand also that there's new markets available if you actually dare to look out from the window and maybe think a little bit outside the box. Is that correct? But I still want to ask, and I still want to know, will I see a Gigacasting on the next Eurogas in 2026? Made in Rheocasting.
Yeah, you have to buy a ticket and go there and have a look.
I will, I can promise you that.
Then I will ask you a different question. Do you love working with the Gigacastings?
I love working in the foundry industry and new challenges and so on. And I think Gigacasting is fantastic in such a way because that increases the scope of the casting. I mean, this we talked about earlier, that it produces castings and so on and so on. I think that the major driver for reducing and shrinking the market for high-pressure die-casting is actually not Gigacasting. It's actually the electrification of the car or the vehicle. And I mean, I would love to show the world that Rheocasting is the right way forward to make a Gigacasting, Megacasting, because you can use a more suitable alloy. You will have longer die life. The shot sleeves, the plungers, and all that will live longer, and you can use a smaller die casting machine. And all this drives to a cheaper end product, and in the end, a cheaper product for us as consumers on the market.
Hopefully without sacrificing on the properties.
Will be better.
So you get the win-win.
I think these
the better
are
product for cheaper price.
That goes by nature, because if you can't do a better product, then you don't really have the right to exist in a developing market, so to say.
I would say that sentence there in the end was actually the best way of ending a podcast about Gigacastings. In a podcast that's supposed to be about money, margin, growth, and new markets, right?
Exactly.
Absolutely. And I think we end on that note. Thank you for listening. Please don't forget to subscribe, and we hear us in the next Gold Nugget. See you until then. Thank you, Per, for joining.
Bye-bye.
Goodbye.
Thank you. Bye.